everybody. I'm Kyle Marsh from the Microsoft Identity and Network Access team, and I appreciate your time coming to my session here at Build. Today, I'm going to talk about how you can make your application more secure, as well as making it more resilient by using one of our latest features, Continuous Access Evaluation. Let's start by looking at how an application works when we're using modern authentication. So instead of typing up a username and password screen, we ask the identity provider, Azure AD in this case, for example here, a token to call Microsoft Graph. Now, we can only do this. What happens next is the private conversation between the user and Azure AD takes place. We can then check for things like, is the conditional access policy being fulfilled? Does this user need to do an MFA? Are they in the right network location? Is there a high risk, etc.? All of those checks happen here without your application having to write any code for it. It's simply part of the package we provide in Microsoft Identity Platform. And then, assuming everything is good, we can go ahead and issue the tokens, an ID token for you to know who the user is, an access token so your application can call Microsoft Graph. Now, the thing is, this transaction only takes place every 60 to 90 minutes. Nowadays, Azure AD issues tokens somewhere between 60 and 90 minutes. We used to always issue them from 60. Now it's maybe somewhere in the middle there, somewhere in that, say, around 75 minutes. And that's the only opportunity we have to make sure that the user still works at the company, that they still have access to this resource, that those conditional access policies I mentioned, have they been fulfilled? And in this world of zero trust, where we want to verify explicitly, these need to happen on a much more regular basis than maybe every 60 to 90 minutes. But we don't have that opportunity because your only transaction with us is when these initial tokens expire. So how can we add a continuous nature to this? Well, one of the things that happens if I take that access token is I want to use that access token in order to enable my application to call to an API like Microsoft Graph. And quite often, my application is going to call Microsoft Graph a lot, continuously, if you will, throughout its running. So I get an opportunity to use the token much more often than I go and acquire the token. Now, the standard thing that would happen with Microsoft Graph is it needs to authorize that this JSON web token that represents you to Microsoft Graph and your application's authorization to call that API, well, it goes ahead and checks that the validity of that token. One of the things it needs to do about every 12 hours or so, not that often, is get our list of signing keys. These JSON web tokens are signed so that they can be validated, that they haven't been altered or changed in any way. But we don't need to call back to Microsoft Identity, don't need to talk to Azure AD every time somebody calls the API. We simply need to get those signing keys every 12 hours or so. Instead, we're relying on the lifespan of the token as dictated by the claims within that token. In that token, there's an EXP claim that says when the token expires. There's an NBF claim that says not before this time is the token valid. So as a result, this token is good during that time frame. So if I issue you a token for 75 minutes, your application will be authorized to call this API on behalf of the user for that full 75 minutes. So in order to be able to shut off that access for that application before the 75 minutes is up, one option is to implement something called token introspection. Now, what this would mean is instead of giving you a standard JSON web token, we'd give you some opaque string that would represent the token to Azure AD. And then every time someone called your API or made a call to something like Microsoft Graph, that would in turn have to make a call back to Azure AD in order to validate that the token is still good and find out exactly what that token means. It's a very expensive operation. You're waiting a lot longer to get those responses from your APIs because we've added another round trip over the internet in order to make that call work. So it's not something we're particularly interested in terms of providing a token introspection process. Instead, we've been very intrigued by the work that's been going on in the OpenID Connect's Shared Signals and Events Working Group. In fact, we participate very heavily in that group. And we can see it as an opportunity as we start to adopt some of their standards as they start to come out to improve this process quite a bit. So what we're going to do is, well before we even have an application in the picture, the API, in this case Microsoft Graph, can set itself up to be a listener of events from Azure AD that pertain to the users who might be getting tokens for this API. So we set up a push channel, so the Graph API isn't polling all the time to find out what's going on. Simply when there's an event that that would cause us to say, hey, you shouldn't accept that Graph token anymore, that token to call Microsoft Graph, we can send that event, push that event directly to the Microsoft Graph API implementation. Now, when your application comes along and gives a token that it might have been issued maybe 35 minutes ago, it could give you that token. The Microsoft Graph API can look and say, hey, do I have an event for this user that says I shouldn't accept the token that was issued before, say, noon, and yet here it is at 12:30, and I shouldn't accept the token because I got a message saying no tokens before noon, and this token was issued at noon, and it's 12:30. So I could see where I could need to revoke the access based on when that token was issued. Right. So if I got a message that said no tokens before noon, and this token had a issued time, the ISS claim in the token of, let's say, 11 a.m., we would reject the token. Now, what's changing for you as an application developer, I should mention the types of events that we would use to revoke that token, if you will, or revoke the ability of that token to access Microsoft Graph, could be things like the user's changed their password, maybe the user's been deleted or disabled. We even can use things like our Azure AD identity protection. And if the user were to move into a high-risk category, perhaps an impossible travel situation has occurred, or their activity is coming from an endpoint we know, or an internet address we know where a lot of bad actor activity is happening, we could also require send a message to Microsoft Graph saying, hey, continuous access evaluation is saying, don't accept this user's token if it was issued before noon. Now, Microsoft Graph and the API can also participate in this on their own. So every time we call Microsoft Graph from an endpoint somewhere on the network, of course, Microsoft Graph gets the IP address of where that request is coming. If I have a conditional access policy that this resource should not be accessed unless the user would say on my corporate network or in these particular network locations, then Microsoft Graph can say, well, gee, this user's not coming from that IP address anymore. Let's reevaluate to find out if this user really should still be able to access the resource from their current location, and it gives us another opportunity to enforce those conditional access policies, those location-based conditional access policies. Now, if Microsoft Graph had been given that error, that continuous access evaluation event that says no tokens before noon, and this token has been issued at 11 a.m., then it's up to Microsoft Graph will then return something we refer to as a claims challenge. So you'll still get your 401. You're now unauthorized. Now, you might have used this token a minute ago, and it's good for another hour, let's say, but you'll get in the 401 unauthorized because continuous access evaluation is kicked in. We will include in that response a www.authenticate header, a bearer header, saying I've got a bearer token here. And what we'll do then is we'll have, for example, the authorization URI will point you back to Azure AD. There will be an error of insufficient claims. And this third component we call a claims challenge. This is simply an encoded version of a string, something like I would have seen down below, where we're saying this token is no longer acceptable. So we're returning a 401 unauthorized to your application because the token is no longer acceptable. And in order to have an acceptable token, it needs to meet this particular claims challenge, in this case, not before the specific time that's issued here. So as an application developer, I take that 401 and the claims challenge I get from calling Microsoft Graph, go back to MSOL, ask for a new token, providing this claims challenge, and then we would go ahead and get that application would get the proper token to go on and call Microsoft Graph. Let's take a look at how this works in action here. So I have here a couple of applications. Let me get this out of the way for a minute. So on the right here, I have an application that doesn't support continuous access evaluation. So I'll go ahead and sign in the user here, and we're going to sign in Moses, and we'll go ahead and do his authentication. Oops. Okay, so I get my standard token here. That's my ID token that's telling me who the user is. It's Moses. Great. Notice I can look at my token response, which tells me how long this token is good for. And here I see that this token expires in about an hour from now, from when I'm making this recording. If I go over to a slightly different version of this application that does support continuous access evaluation, let's come here. We're going to sign in as Moses here as well. And I get, obviously, a very similar looking ID token. It's still Moses after all. But if I look at the token response now, I see some very different values. First off, this token is going to expire about a day from when I'm doing this recording. Not an hour, but a day. It's a 24-hour, looks like it's about a 23-hour token here. Well, 24-hour token. So that's one thing. My token lifespan is expanded. I no longer have to ask for tokens from Azure AD every hour. That's nice, a nice gain in efficiency for your application. But also, there's another value here that's been set, which is this refresh on. So notice back here on the right, we don't have a refresh on value. Didn't get a refresh on back from Azure AD, but we do when we support continuous access evaluation. That's a cue to our MSOL library to start trying to renew this token after we've gone ahead, after 12 hours of life. So I've got a token that's perfectly good for 24 hours. After 12 hours, MSOL will go out and start trying to refresh that token. If it can, great, I got a new token, another 24 hours of life. If it can't, because there's some issue between anything going on between your application and its ability to get a token, well, it doesn't matter because I've still got another 12 hours of lifespan left. So any outage in your application's ability to acquire a token that's less than 12 hours, your application won't notice. And that would be a tremendous issue for us to ever be out anywhere close to 12 hours, let alone just a couple of hours. So it would be so it's highly likely that if there's any interruption, your application simply won't notice because it still has valid tokens that it can use. Let's go ahead here. I'm on my IT Pro. I've come in. I'm looking at Moses' sessions here. I'm going to revoke all of Moses' sessions because maybe Moses lost one of his devices or some of his devices. So we're going to say, nope, Moses needs to re-authenticate on all of these devices because something has been lost. So now I'm going to go and let's look at the changes we need to make to our application. First off, I have here, I'm calling an HTTP web-based application, just at a raw form here, just so we can look at the innards of the code, if you will. First off, obviously, I don't need to worry about if it's a successful response. But if it's unauthorized, then I need to look for that www-authenticate header. And if there is such a header, then I can look to see if the error in the header is for insufficient claims. And then I can go ahead and check for my claims, then my claims challenge. If it's there, I can decode it, and then I'm going to go off and acquire my access token again, but now I'm going to pass along the claims challenge. And what we're going to do is when we go ahead and call to get an access token, first off, we're going to do our standard pattern we always do with MSOL. We're going to acquire token silent first to see if it can be acquired without bothering the user. Perhaps the reason for the token acquisition was, or the continuous access evaluation rejection was the user changed location, but by the time they're accessing it again, they realize they move back to the proper location, so I might be able to acquire it silently, or highly likely I might need to fall back to our user interaction required, and then I'll go ahead and acquire the token interactively. If I've got this code in my application, right, I've got my code to take the claims challenge that's returned from Graph when CAE has been kicked off, and then return it and use it back to Azure AD to acquire the token again with our MSOL libraries. I can also add the client capability of CP1 to my application, and whenever that's the case, then we know that your application understands continuous access evaluation, and we can give you those long-lived tokens, as well as be able to cut off access to the resource based on the continuous access event and not just the lifespan of the token. So here, On the right again, we have an application that doesn't support continuous access evaluation. And I'll go ahead and call the Microsoft Graph profile API, and I have no problem here. I can still access this user's profile. I'm allowed to call Microsoft Graph until that token expires. Here, I'll go to the application that does support continuous access evaluation. Let's try to call the profile API there. And sure enough, continuous access evaluation is kicked in, and the user has to re-authenticate because I invalidated all of the sessions for Moses there. So I have to go ahead and sign in again in order to access the application. Now, this application on the right, it will catch up eventually. If I look at my token response, about 58 minutes from now, this application will finally have to re-authenticate. But this application that's using continuous access evaluation, much more secure. Its access was cut off near real time in just minutes, and we didn't have to wait all that time, all that 58 minutes for the actual token expiration to happen. So that's why our applications are more secure. We can cut off access to the resource in moments rather than whatever the life of the token is. And the application is more resilient because it has an ability to proactively refresh a token well before the token expires. So continuous access evaluation really does boost your session protection, right? We now have a dynamic session lifetime. It's based on the events that are happening around the user. Again, if I lose a device, if I change my password, if I need to do an MFA, all of this can be taken into account, and the application and the resource can behave accordingly because they can work on these signals effectively in near real time. So what's next for continuous access evaluation? We're going to be working on making continuous access evaluation work for client credential flow applications. So today they work for applications with users in front of them. We're working to make it work for client credential flow applications as well, so a service principal, if you will. And of course, we're going to make it so that you can have a continuous access evaluation for your own APIs. Today, Microsoft Graph supports some, Exchange supports some, SharePoint supports CAE, and we'll be working to do more Microsoft APIs, as well as giving you the tools so that you can add it to your own APIs as well. So thank you very much. I really appreciate your time coming to this session, and enjoy the rest of Build.